For y'all that are just starting to join us, my name is Tyler Collier. I'm with the Lycos Geosystems SmartNet group, and we'll be going over SmartNet real-time network topics. We have a bunch of different stuff to cover today. Here's a basic agenda. We'll be doing a little introduction, talk a little bit what are GNSS networks. We've got all flavors of folks on here, from neophyte, new users, to experienced operators. Network types, the different types of networks that are out there in the marketplace today. Talk about specifically the RTCM 3.1 master auxiliary concept, which is the MAX concept, which we use inside of SmartNet. We'll talk about integration of GNSS messages because we are a network that's open to all makes and models of receivers on the rover side. It's very important to understand how these messages play, also how you can best use them if you are using a different flavor of equipment than like out there. Talk about using network RTK specifically, some tips and tricks of using it, some terminology that's new to some of our users that have now been transitioned in various different regions. We'll talk about specifically what is SmartNet, also about what we're going to be doing moving forward, also, and in addition to that, talk about the adjustment that'll be coming up here in the coming months. We'll also have some questions at the end. As always, we are recording this webinar, and we will have a link to post for any of your party chiefs, guys that might be out in the field that want a little bit more information and need to be able to use this. So with that, we'll get kicked off. So what is a GNSS reference network? If you guys are using it, hopefully you know what the pieces and the parts are, but we want to cover it just to kind of give you a general overview of what we're doing. So when we start talking about GNSS reference networks, we've got to kind of start where it began, which is base station. Base station being what we set up every day on a tripod and we go out to work. Now, some of the problems with this, of course, is it was temporary. Owner use only means only one person can use it. If somebody else is using it, you guys have been out there with radios and picked up a different base. Coordinates don't match. Things don't look good, and it causes a lot of problems. The other issue is high cost. You had to buy the station yourself. You had to operate it, have to have a man there to make sure it didn't run off. Those tripods with 3 legs run pretty quick. After that, you saw permanent reference stations begin to be put in. They were fixed, usually for private use only, and they were proprietary. These were typically in city-county governments, water utilities, those type of things, where somebody served just one fixed area, and with a permanent reference station themselves, they had the ability to put it up and broadcast. This was great for them. They knew the information about it, but for the general public and for surveyors in general, it was difficult to either get access to this or know anything about it. Along about the same time, you also saw the growth in the CORS network, the continuously operating reference station network by NGS. Of course, we had both the national frame and then the cooperative frame at that point. These were great because they were a standard coordinate frame, active control that'll let us, constrain our adjustments and constrain our control networks to an active control system as opposed to passive monumentation that can get disturbed or destroyed. And of course, the industry standard RINX occupation files were available so that you could process against them and not have to reoccupy passive control monumentation. And this, of course, then led us into network RTK. This was has been going on now for a few years, but it covers, of course, wide area RTK. It's economical, and for the most part, it's standard. We here at SmartNet do believe in standards, and you'll see that as we go through the presentation. Aside from the evolution of it, you also have the different components. We're not going to spend a ton of time on this, but there's 5 basic components that we're talking about when we're talking about reference station networks. We've got the GNSS hardware, monuments, software, the IT infrastructure and comms, and then, of course, you guys out in the field as users. So the hardware, this is the key component of the network. This, of course, has the functionality to communicate, interfaces with the server software, being able to track different satellite constellations, having a high-quality receiver clock, and be very flexible for remote communications and remote deployments. The most important part, of course, of the network, aside from the user base, is the quality of the components you put out there in the field. And one of those components, of course, is the reference station. With the reference station, you want it to be a very low noise floor reference station. You want to have a high quality antenna that's very stable, that's resistant to multipath, because all we're always doing in GPS is trying to fight noise. And if we start with a noisy element at the receiver or the antenna, then by the time we get it out to RTK broadcast, we're going to have noise in the system that we have to fight through, which is what we want to get rid of. Other key component, of course, is the monumentation. A lot of installation considerations to be taken into account when you start installing a reference network. At SmartNet, we try to adhere to the NGS core specs as best we can. We'll talk about that a little later on in the broadcast. And of course, providing documentation for your users so that they know what how your deployment's been done, how your monuments are mounted, and get all the pertinent information that they need. That's one thing that we're working on very diligently, and we'll talk about that here in a little bit. Software, won't spend a ton of time on this, but for us as network operators, it's got to be modular and scalable. For our scalability, for example, we need to be able to cover North America. It needs to meet requirements for multiple applications, be able to handle us being a very large network, probably one of the largest in the world, be able to handle post-processing, RTK, and be able to take different types of receivers in, be it from legacy receivers back in the 500 days to current GR10 receivers for Leica, or even if the need arise to be able to bring in alternate receivers, Trimble, Topcon, what have you. Of course, it needs to be, for us, easy to install and manage. On a smaller basis, our software is very easy to install and manage. On the scale that we're working at, it is a full-time job, and that's why we're here. IT infrastructure and communications is important both on the server side, where the receiver to the server, as well as from the server to the users out in the field. This, of course, is the largest point of failure that we run into on a day-to-day basis. The software is very stout. The receivers out there in the field are very stout. The monumentation out in the field is very stout. The usual failing point is here in the comms, either from the receiver to us because either of cable modem, DSL going down, local IT changes, firewall changes, interrupting the data flow from the receiver to us, or vice versa. When you guys get out in the field and are working, of course, your cellular modems coming into the network. Cell coverage, of course, is a necessary evil. There are some ways around that using an RTK bridge, local radio broadcast, those type of things that are available for certain instances and deployments. And this just kind of gives a basic overview of a network architecture, just in case you guys were wondering what we're dealing with when we start talking about the network. We've got, of course, our rovers, or excuse me, our receivers out on the left there, deployed, of course, for us across all of North America, and then our site servers, which can command and control the receivers, our network server, which brings that data together, and then commands the cluster service to control network processing. Then, of course, it crosses the firewall out into the RTK proxy. That way, the network is secure behind a firewall, and the only thing exposed to the external world is the proxy server. And, of course, then we have our spider web, which is our RINEX files, and our portal access. So this is just a general architecture. Ours is a little bit more complex. I think we're now up to 48 servers, controlling 415 SOS stations throughout North America. So ours is a little bit more complex than this now, but this kind of gives you a view of what individual regions would look like. So that's the general components. Just wanted to kind of go over that quickly. Old news, hopefully. The next part is the network types. So there are varying network types out in the marketplace, and want you guys to kind of understand the differences. We won't get into the all the details of them because we do want to keep this a little higher 30,000-foot view. If you do have additional questions on this, we can definitely provide documentation, and there is things on the website right now that help explain this in greater detail. So to begin with, the motivation for network RTK is pretty simple. We want the ability to model and estimate distance-dependent errors. And those three main sources of error are the ionosphere, the troposphere, and the satellite orbital errors. So you can see in this little graph here that we have at different points different types of errors, different types of noise that creep into the system. And with network RTK, we're trying to mitigate these to the best of our ability. We can't completely eliminate them, but we can model, estimate, and try to eliminate the best we can. So what does this mean? Well, if you start with the old way of doing, having an RTK network where you have single bases that are operating all independently, you can see as I'm close to the reference station, as you guys have all experienced, my accuracy, reliability, and availability is very good. As I start moving further and further and further away from the reference station, those three attributes become very poor. So what we're trying to do with network RTK is we stream all this data into a central server, and when we do this, by having all the stations in working concert with one another, we're able to create a more homogeneous solution over the entirety of the network. And you can see here from the spacing that we're talking about, typical station spacing for what we try to hold a SmartNet is somewhere between 50 and 70 kilometers. This is designed for when we approach solar max, so we can still produce high-quality corrections and models. There's three main network types that are out in the marketplace today. FKP, which is an area correction parameter representation. This is more of a European correction. I'm not sure. I don't know of any deployments here stateside that are using this in a production level network, so we won't really speak to any specifics on it. We have the MAC correction, the Master Auxiliary Concept, which of course is what we use in SmartNet. It is the industry standard. VRS, which is a virtual reference station modeling and representation, which is was brought to light by Trimble back in the late 90s. Issues affecting each one of them, all of them, you always got trade-offs with no matter what type of network that you're working on. FKP and VRS are proprietary modeling of network corrections. This means that there's no standard documentation that tells you how the server-side information arrives at their answers. FKP and VRS are mostly non-standardized formats. This means that it kind of ties in with the next one. The messages contained are model data, not raw data, as specified by RTCM. So if I'm broadcasting, if you think of the broadcast as a container, if I'm broadcasting a container that says it's RTCM3, for example, but the message inside the container is not of a standard, then it doesn't fit the overall standards. And so with FKP and VRS, those messages are modeled. They're not raw data. The MAC correction does have a possible side effect if it requires higher bandwidth for transmission. This isn't generally a problem in even 2G networks, especially with 3G networks as far as cellular communications go. And we're typically only broadcasting between 5 and 8 stations of data, so this usually isn't an issue when you're talking about cellular high-speed communications. If you're trying to broadcast over radio or at 9600 baud, it could be an issue, but typically isn't. VRS only, it is a duplex communication, which means it does require a two-way communication between the rover and the reference network, and it can have a limitation of the number of simultaneous rovers it can support, both because of licensing as well as server hardware. With VRS, all the processing is done on the server side, so it does require the network operator to be able to support a full load of the rovers they have out there. With a virtual reference station, like I said, it's been around a while. And when it was initially introduced back in the late 90s by Terasat and then acquired by Trimble, it was a really good solution because of the lack of power on the rover. It being a server-side processing, it allowed the rover to be much lower powered as far as its computational processes, which, if you think back 10 years ago, how far we've come in miniaturization and processing power on the rover side is pretty amazing. So the basics, what happened, the rover, the network, the stations in the network broadcast their information back to the network server. The network server then computes a network ambiguity, a common ambiguity level for the sources of error across the entire network. The rover then will broadcast its position back into the network. The network would then generate and send a virtual correction for a station, a virtual station that doesn't exist there next to the rover, so it could be 1 meter, 2 meters, 200 meters, and then the rover makes a computation over that short baseline from that virtual station. So some of the problems with this, of course, like I said, it's not standardized, does require two-way communication, and the network information is lost. So not all relevant information is available to the rover. So the rover only gets the common satellites that are available on the network. So if Station A and Station B only have 5 common satellites, the rover, of course, is only going to see 5 satellites for its use out in the field. So again, this is an older technology, still in wide use today, but it is used primarily now to support legacy products. So this led to the development of the RTCM network RTK message format. Because VRS was not a standard, it still isn't a standard. It's widely used, but it's still not a standard. The RTCM committee came together and said we needed to do something. Well, who is the RTCM? RTCM is founded in 1947 as a U.S. State Department Advisory Committee. It is now completely independent. It supports the development of GNSS message and format standards throughout the world. Membership includes 22 government agencies from 7 nations, 56 manufacturers from 14 nations, and 41 other stakeholders. And the Standing Committee 104 focuses on differential GNSS standards. So who is RTCM? It's pretty much anybody and everybody that has anything to do with GPS. So manufacturers, Trimble, Topcon, Leica, Sakia, all of those players are part of RTCM. So it is a standards organization. So here's kind of the genesis and the timeline of how RTCM SC104 set up and started with version 1 going all the way through version 3. And you can see, if we get down to the bottom, version 3 was primarily aimed at approving RTK and supporting network RTK. So this was one of the key components of developing a standard was RTCM version 3. So the concept that came out of this SC104 was the Master Auxiliary concept. The MAC was proposed as a standard for network RTK corrections. It was proposed to overcome the issues with the existing approaches, to provide interoperability between network and rover systems, and transmit all relevant network correction data to the rover user in a highly compact and standardized form. It has been ratified and accepted, and it is the industry standard for network RTK. That means everybody had to accept it. Leica, Trimble, Topcon, all the major players had to accept that this to be the standard, and now it's incumbent on everybody to, of course, adopt that standard. So that's where RTCM 3.1 came from, and now we'll talk a little bit about the implementation of it. So we can break the idea of what we're talking about into a few different components. We can talk about the network, which is the overall combination of all the stations that we have, and then we can step down to the cluster level. The clusters are where the network ambiguities for the common satellites are computed. So you can see in this graphic here, we have 3 different clusters. You can have overlapping clusters, but the reason to have multiple clusters is to maximize the number of available common satellites. For example, if we had a statewide network, and we had one cluster that covered the entire state. On the eastern edge of the state, we may see 1 set of satellites, and we see 8. On the western edge of the state, we may see another 8 satellites, but we only have 5 common satellites between both edges. That means that the cluster can only compute ambiguities between those 5 satellites. So we're going to minimize the number of satellites we have available. So that's one reason that we adjust the clusters. Another reason can be a mixture of equipment. So we could have GPS and full GNSS equipment out there, and so mixing them can cause issues. So we can mix clusters so that one can be GPS because that's where we have primarily GPS equipment. One can be GNSS. Another reason, of course, is processing power. These clusters, if you make them too big and the cluster has to process too much data, it can have negative impacts onto the network. So this is the things that we have to think about when we talk about clusters. So this is where we compute the common ambiguities, the common sources of error between all of those stations. When I get inside the cluster, I get down to the cell level. On the cell level, this is where, as a user, I would log in, and I can either, as an operator, manually define a cell and say, okay, for this area, these S8 stations will be used, or we can do an auto cell, which is what we do with SmartNet, and when the rover logs in, it sends its position in, and then the network says these 5 or 8 stations best approximate the error in your area. On the cell level, we have the master station, and then we have the auxiliary stations. The master station is where we get the full complement of corrections to the rover, and the auxiliary stations is where we get the differencing information from the other stations. We don't need all the corrections from all the auxiliary stations. Again, we want to keep the size and bandwidth small. We just need to know how much the corrections from auxiliary 1, 2, or 3 would differ from the master. So if we look at the steps that we talk about in network positioning, these are all the steps that we have to go through either on the server side or the rover side. And the reason we're showing this graphic is we can show what's happening on the network level. So if we have the reference stations at the top and the rover at the bottom, we have 5 different steps to take to be able for the rover to calculate a position. If we're talking about a master auxiliary correction, you can see that most of the processing actually happens on the rover side. So with the network software, of course, we fix the common ambiguities between reference stations at the cluster level. We then calculate the errors for each reference station. The rover receiver tells the network where it's at. It then can interpolate and estimate the reference errors to the location of the rover, apply the corrections to the data from the master station, and then process its position. And we'll talk about this again in just a second. So these are the 5 steps that we have. 3 of them happen on the rover side, 2 of them happen on the network side. So how does this work? Well, you can see in this graphic that the rover receives the carrier phase information from the master station. So it receives, again, the full complement of corrections from the master station. And then it receives the auxiliary stations, the differencing information. So if in this graphic we have 5 auxiliary stations and 1 master. Rover logs in, gets the master correction, and then it gets its differencing information from each one of the auxiliary stations. This allows us, of course, to provide optimal correction differences for the position of the rover. It can interpolate them based on where it's at relative to the other stations, and because they're all leveled to a common integer ambiguity level, everything fits. And then we can provide, of course, the double differencing phase residuals of the master rover baseline. The benefits, because it is standard, all processes are fully described and documented. There's no need for additional proprietary messages. Full interoperability is guaranteed between rovers and control centers, as well as between different control centers, so we can swap data with other folks if necessary. The network software is transparent regarding the reference station data. Again, everything is sent out to the rover, and the network operators can then concentrate on providing additional services, and rovers will finally perform optimally. So our realization of MAC is what we call MAX, is shown in this graphic. The rover would be seen in the middle with the stations surrounding it. All the stations broadcast their information back to the network RTK server. Common ambiguity solution is computed for the entire cluster. The rover sends its position into the network. The network can then say, okay, this master and these X number of auxiliary stations best approximate the error in your area. It sends a full complement of corrections from the master station. It sends the differencing information from the auxiliary stations, and then the rover can use that data to compute the ionospheric, tropospheric, and satellite orbital models necessary for its location. The good things, of course, is it transmits all raw data from the master and ambiguity level correction differences. It can do 32 sites, so if we were using a radio broadcast, that we could broadcast out 32 one master and 32 auxiliary sites, so we could use radio if necessary. It's fully standardized format and content defined by RTCM 3.1. There's no smoke and mirrors. We can hand a white paper that documents exactly how we do what we do. It works in a two-way and broadcast mode. So the way we work typically in SmartNet, of course, is a two-way mode where the rover sends a position into the network, and then the network sends a correction out to the rover. But of course, we can use radios in certain applications. All relevant information is available to the rover, so the rover can adapt to the local environmental conditions if necessary. The rover algorithm is able to use the data in an optimal way. It can use it for multi-base positioning, non-fixed satellites, and even fall back to single baseline RTK. And of course, this depends on the rover and the implementation of the algorithms on the rover side. So this would be manufacturer specific. One of the downsides, of course, it could be slightly higher bandwidth usage depending on cell size. So this can be a downside, but like I said, for 3G networks, it's typically not an issue. A question just came out: does Max support sending the name of the auxiliary station rather than just the number of auxiliary stations? For project documentation, it might be helpful to know what stations went into the Max solution. No, that is not part of what can be we can be broadcast, but not what's typically recorded by the rover. We are working on the user portal where you could download a PDF version of basically a field book on a daily basis or whenever you needed it, that would tell you what auxiliary stations were used, in the production of that Max correction, a detailed log file, if you would. And we're working on that. If you do need that right now, you can place an email in, and we can pull that for you. Don't overwhelm us with that, because we won't be able to do for everybody immediately. But we are working on a piece of the portal that will allow you to do that. For a non-physical reference station, so VRS, or even what we consider our Imax solution, you can see where the steps in the network positioning are happened. Everything happens server side. And this, of course, again, is to support legacy rovers that are not capable of receiving a MAC correction, in the field. And so you can see 4 of the 5 steps are done on the network software side, and then only 1 step is done on the rover side. So for us, the realization of this is called our Imax solution. So what happens here is very similar to a Max in that all the data is sent from the stations in the network to the network RTK server. A common ambiguity solution is computed. The rover sends its approximate position back into the server. A network solution is then computed, and a master station correction is broadcast to the rover. Now, the master station correction has model data in it. So what the software does is it adjusts the correction for the master station in a way so it would reflect the effects of all the auxiliary stations. The rover, of course, only sees a single baseline, but it does see a real single baseline to a real station, whereas with the VRS, you are getting a vector off of a virtual station that doesn't exist. So it transmits computed data that is referenced to a real reference station, so that's a good thing. So I can have a real baseline at real distance. Of course, this comes in, it's very important when we start talking about how 3D quality and HRMS and VRMS values are calculated on the rover. They are predicated on baseline length. So if I have a long baseline, my rover is going to reflect a more realistic 3D quality or HRMS or VRMS value compared to a VRS solution, which is going to be based on a 2 or 3 meter, 200 meter baseline. The other thing, it does force the rover into a long baseline processing because it is at distance, as opposed to, again, with a VRS solution, using a short baseline processing, which can, again, cause problems because the rover's not trying to do any of its own local ionospheric modeling or anything. We can use commonly understood base station formats. Excuse me. So we can broadcast RTCM 3.3, 3.1, and to the rover, it looks just like a single baseline. So the rover doesn't see multiple base corrections coming into it. It's very compact because it is a single baseline format. Of course, the content of the message is not standardized. It does require two-way communication, and the network information is lost. So not all relevant information is available out at the rover. Is the RTCM station ID on Monday the same as it is on Friday? Yes, and I'll show you how you can look that up here in just a second. So network methods with Imax, it is an individualized network RTK method developed for older receivers that can't support MAC. And for Master Auxiliary Concept, RTCM 3.1, the network standard, it's the only method that gives the rover the control to calculate the distance-dependent error corrections itself, meaning the rover can adapt its calculations as it determines necessary for local environmental changes. With Master Auxiliary Concept, MAC is the only one that's both, from real reference stations, that's both traceable and repeatable. Of course, these are very, very important as you're out there in the field and you're working traceability and repeatability. So again, you can document. If you get called into court, you can answer the question of, yes, yes, Your Honor, I was tied to this reference station at this time, and have that in your back pocket. So, what does this all mean? You know, ambiguities and ionospherics and tropospherics and, you know, all that good jazz. At the end of the day, what does it mean to you guys out in the field? Well, as they say, a picture is worth 1,000 words. So this picture shows a subset of the network in Iowa, for example. And you can see we have 7 stations shown in this graphic. You can see that the standard distance between the stations is going to be between 50 and 75 kilometers. And what this shows is a residual ionospheric error for single baseline RTK. Okay, so we can actually you know, approximate and tell you what the approximate errors based on the ionospheric residuals are in any given area using the processing software. So you can see if I'm close to the reference station, as you saw in one of the graphics, the green was good and red was bad. In this graphic, the blue out to 15 kilometers, you can see that we're not incurring a great deal of error. We're incurring, you know, in the centimeter world of error. But when we get out at say 35 to 40 kilometers, we're now getting into that 3 centimeter world of error. So not only do I have the systematic error of GPS of 1 centimeter horizontally and 2 centimeters vertically, but I also can now add, you know, 3 centimeters of ionospheric error into the equation. So from a measurement now went from 2 centimeters when I was using single baseline and I'm up close to the receiver. When I'm working at distance, say 40 kilometers, now I'm at you know, additional 3, so I'm at 5 centimeters, 16, 17 hundredths. When I start working with network RTK, you can see here, same graphic, same 7 stations. Now we've knocked that 3 centimeters of residual ionospheric error, you know, down into the 8 mil world, 4 mil world, somewhere in there. So as opposed to having that 2 centimeters plus 3, now we're at 2 centimeters plus, say, 6 millimeters. So we're at you know, just over the systematic error of GPS. Like I said, we can't completely eliminate the ionospheric, tropospheric, and satellite orbital error, but we can mitigate it for most all purposes. So what does it mean in the field? With standard RTK, you can see we're working, and with network with RTK with network correction parameters, we have longer range and higher accuracy. There's a long question that we'll take offline, or we'll answer towards the end once I have a chance to read it. But we'll keep on going on. So another component of the network that we have to deal with is supporting current and future satellite signals. And we just want to cover this real quickly, just so you guys kind of know what's going on. I know there's a lot of information out in the out there, some of it good, some of it bad, and this question typically comes up. But it's also very important to understand current and future satellite signals and how they're affected by different brands of equipment. So us being primarily Leica equipment in the network, understanding from a rover perspective how that affects you is very important. So with L2C, there's currently, I believe, 8 Block 2 RM satellites in space, and the next generation is the Block 2F. They're going up. Older GPS satellites will be placed after they reach the end of their expected life. And L5, the third civilian frequency, a 2 RM satellite was launched that had L5 capability in August of 2009. It was a test signal only. There was actually a launch of a fully functional Block 2F satellite on May 27th of last year, and it went into service in August, I think August 31st, I think it was officially announced, 2010, that it was available. Currently, there's 11 additional Block 2F satellites shown to have a to-be determined launch date on the Boeing website. So if you go to www.boeing.com and you type in satellite launch, it'll actually bring up a table and show you all their satellite launches. There's none that have a date on them right now for L5, so at this point we don't have to worry about L5 at this time, and I don't see us worrying about it for another couple of years. The problems with this is with the differences in constellations. So we'll have L5 satellite broadcast in L5. We have a couple satellites broadcast, or 8 satellites broadcast in L2C. The effect is that not all satellites provide the new signals at the same time. The mixture of satellites have different types, and we can have phase-based shifts based on different codes depending on the different manufacturers. So this is something that we have to take care of on the network side, and as well as you have to know about on the rover side, because some manufacturers do different things to bring L2C in line with L2 in regards to phase shifts. We can provide more documentation on that, but we don't want to spend a ton of time on it. But we'll tell you how we fix it. Which brings us to GLONASS. GLONASS, of course, had a fully operational constellation in '95. In 2001, only 7 were available. Only averaged 2 in a view at a time. I didn't have a whole lot of value. When there was an investment in the constellation by the Russian Federation along with India, they actually started broadcasting 3 to 6 satellites per year, and that brought us to I think today we have almost a fully operational constellation. I think there are 1 or 2 that are turned off, so we're getting close to a full GLONASS constellation. Again, this causes problems on the network side when you start intermixing different manufacturers, both on the network and the rover side, because of different biases and phase ambiguities, how these are handled by the receiver, and these biases have to be modeled or calibrated. Otherwise, we can have ambiguity fixing to be affected. And we'll talk about how that affects you guys in just 2 seconds. The Galileo constellation, I'm not going to spend any time on this because at this time it is still a pipe dream. Initially it was supposed to be fully functional in 2008. As of today, there are 2 satellites up. They're both test satellites. There's hope that they'll launch 2 new functional satellites this year, and hopefully by 2018 they'll have 22 operational satellites. This is down from their original 30 satellites that they had hoped to put in orbit because of funding issues. So right now we're at a delay of approximately 10 years. So at this time, I'm not going to spend much more time on it. But this does affect us going forward. We do want a fully GNSS capable infrastructure out there for you guys, but there is an issue that affects everybody, especially if you're using mixed equipment on the network. So the related issues are, of course, the L2C phase shifts. Everybody handles the phase shifts on L2C differently. GLONASS, there's interfrequency biases that are part of it because GLONASS is a FDMA signal, which is a frequency divided. In mixed manufacturers, receivers networks are affected. So the short and skinny of it is The receiving manufacturer needs to be known for all sites in the network. So for us, when we know what all our sites are, if they're a Leica GRX 1200 Pro GG, if they're a Leica GR10, if they're a Trimble Net R8, whatever they may be out in the field, we have to know. And then you as the rover user needs to know what receiver type you're listening to. Okay, so all the issues of L2C, GLONASS, and MISC manufacturers are handled, and we handle them by using RTCM 3.1. And it's the only message that handles this. So if you are a TopCon or a Trimble user on the network today, or any other manufacturer, then and you want to use GLONASS, then the only broadcast that we support GNSS correction on is RTCM 3.1, and the reasons are pretty simple. Because it's the only message that we have available to us that allows us to broadcast the receiver type. So the receiver type allows us to broadcast out what you're listening to, and then your rover will take effect to make sure that the L2C phase shifts are handled properly, or that the GLONASS interfrequency bias is handled properly. You may wonder why your sales reps out there always harp on you about keeping your firmware up to date. This is one of the reasons. This is I won't say relatively new, I'd say a 2-year-old development, but I do know that there's folks out there that are running firmware that's more than 2 years old. So if you're running old firmware and you do not have the ability to use the receiver type message 1033 in the RTCM 3.1, turn your L2C off and turn your GLONASS off. Because it can cause problems on your rover. Okay, we broadcast RTCM 3.1 with message type 1033, and that is the only thing that we broadcast, GPS and GLONASS on because of that issue. So please, please, please upgrade your firmware if you can. If you can't, turn L2C off and turn GLONASS off. That way you won't have any problems. You can also use a non-GNSS message. You could use RTCM 2.3, and you would be able to avert any issues that you'd have out in the field. Okay, we just want to make sure you guys know about that. It's important to us to communicate that to you guys. So again, we're handling L2C phase shifts, we're handling GLONASS interfrequency bias, and we're handling this by broadcasting the receiver type, and then as incumbent on the rover to know what that receiver type is and apply the appropriate phase shifts or biasing models. So use RTCM 3.1. That's the standard message for both network side as well as for GNSS message broadcast. Is the rover or the network broadcasting MT33? The network broadcast message 1033, and it basically says to your rover, you are listening to a Leica GRX 1200 GG Pro, or you are listening to a Leica GR10, or you're listening to a Trimble Net R8. Then your receiver, your rover, can apply the appropriate models to it. So we've got some questions here. Does atmospheric error affect relative precision within the network? Yes, it can, depending on the time that you take the measurements. If you take one at one time of day and you take another one at another time of day, your relative measurements between your stations can be affected. When is L1 going away? Never, to my knowledge. Okay, we got some longer ones here. I'll save till the end. Does that mean you would stop using ADV null antenna, etc.? No, Dave, and we'll get to that in just 2 seconds. Like, really, 2 seconds. Good segue. So some network terminology. There's a couple of our users that are new to SmartNet that have not been using authentication and have not been using network RTK to this degree. So they wanted a little refresher on what these terms are. So NTRIP is the network transport of RTCM via Internet Protocol. So it's a lot easier to say well, I'll put NTIP. It's NTRIP, sorry. NTRIP. It is for authentication and authorization, so it sends a username and a password into the network so that it can authenticate you to use a specific broadcast. We have a source table. It contains all available mount points for that port that you're connecting into. So those are the streams of data that are available. The mount points are the unique data streams. For example, with us, RTCM3 underscore max, RTCM3 underscore Imax would be the unique data streams. And then the stream details has metadata for each of the mount points. We broadcast only the ADV null antenna type. This allows all the phase center measurements to be reduced to a common antenna type, and it removes you from having to switch antenna types depending on the station. So what happens on the network side is we know what type of antennas we have at each one of our individual locations, and then in the processing and before we broadcast out instead of from phase center to phase center, which would be typical in RTK, we broadcast from basically the ARP, so it reduces from the phase center to the ARP, and then the broadcast is made and the measurements made from ARP to phase center of the rover antenna. Yes, Jerry, NTRIP, not ERTIP. So NTRIP is our is how we log in and authenticate. For older receivers that are out there, we still use GPUID, which is just a username and password. We still support that for System 500, for example, cannot use NTRIP, but it does use GPUID. We do recommend that you use NTRIP where possible. It's not a necessity, but we do recommend it going forward. Yes, the mount point entry is required. So if you're using something that you have to hand enter a mount point, you can go onto the connection and configuration page of the website, and it'll tell you specifically for your particular rover or brand what mount point and what the mount point name is. So if you want to receive it, that's the extension, if you will. So if you call in via NTRIP, the mount point would then be the extension so that you get a hold of what you want to get a hold of. So some operational characteristics that have changed. Question came up, how can I find out if my receiver is compliant with MT 1033? Most major branding manufacturers, rovers out in the field, if you have current version firmware, you shouldn't have to worry about it. Feel free to send an email into our support email address, nafta.smartnet@leicageosystems.us, or go on the contact page and let us know what you got, and we'll tell you. I spelled something wrong again. Server side. So the master auxiliary concept, there's been some changes with Spider 4 of how things work. So we want to make sure you guys in the field that have been using either other networks prior to the transition or have seen some changes in the way that the network operates since we did the Spider 4 upgrade, we wanted to give you kind of a quick overview. So on the server side, when a rover logs in, SmartNet, we only broadcast corrections if you're within 50 kilometers of a station on a max correction. So if you are more than 50 kilometers away from a station, we will not broadcast you a max correction. The corrections will roll back to single baseline if your rover travels more than 20 kilometers outside of a cell. So if you were to take your cell, your 5 to 8 stations, you were to draw a border fence around it and then buffered by that by 20K. If you get outside of that, then the corrections actually roll back to a single baseline. The reason for this is it can cause interpolation errors with auxiliary stations and cause less than stellar ambiguity resolution. So we don't want to do that. We'll actually begin rolling this back to the default of 5 kilometers as we move into Solar Max. Again, this is for your protection. We're trying to make some geometric changes to the network from a physical standpoint to address some of these issues that we're having in different areas. On the rover side, operational characteristics, the rover firmware should be intelligent enough to disregard auxiliary stations at short baselines. So if I'm up close to a reference station, for example, say I'm within 3K of my master station, my rover should just completely disregard the auxiliary stations. I don't need to know the ionospheric, tropospheric, or satellite orbital models if I'm that close. They should be the same. The rover firmware should also be intelligent enough to accept a single baseline message if the server stops transmitting auxiliary messages due to either distance, loss of network ambiguity, etc. So if I'm a rover and I'm within 3 kilometers of a station, I should not receive the auxiliary corrections. The rover should disregard them. If I step outside my cell by more than, say, 20 kilometers right now, or if the network were to lose ambiguity solution and only broadcast a single baseline from the master and not my auxiliary stations, my rover should be able to interpret that and keep working. And again, this is rover firmware issues, so some manufacturers don't handle it this way. So if you get outside the cell and it stops broadcasting a max correction, the network stops sending you a max correction, just sends you a single baseline correction, the rover doesn't like it because it's expecting a multi-base solution. So for example, with Trimble, we've run into this in California. If they traveled outside the cell, then they had problems. So if you get outside the cell and you're using a Trimble rover, for example, please, you can automatically swap back to nearest solution or swap back to Imax and continue working. Yes, all rovers. So 20 kilometers outside the cell applies to all brands, and the rovers are the same. Correct. If you travel 20 kilometers outside the cell, the server, SmartNet, will not transmit you the auxiliary stations. It will only transmit you a single baseline. Doesn't matter what brand of rover model that you're using. Some rovers handle it. Some rovers don't. Leica rovers handle the rollback to single baseline just fine. The Trimble rovers have had some problems that we've seen, how they process the data and how they use it. TopCon, we haven't had any reports one way or another. Kenny will answer those two questions offline with you. Imax, the individual master auxiliary concept. Again, corrections are on the server side. The network will not send corrections out if you're further than 50 kilometers away from a station. So again, corrections are only available within 50K. Corrections on the server side will roll back to a single baseline if the rover travels more than 20 kilometers outside the base. Again, the same thing happens. A single baseline is then transmitted. And also on the server side, because the network, or excuse me, the rover doesn't have a idea what's going on in the network. Unlike with Max, on Imax, the server actually will roll back to a single baseline if the rover moves within 3K. So again, Max, all the process, most all the processing happens on the rover. So there's a lot more intelligence on the rover firmware. Imax, there's not as much intelligence on the rover. It thinks of it as single baseline only, so most of the intelligence has to be handled on the server side. So rover side, with Imax, the rover only sees a single baseline solution, no matter if it's at 50 kilometers, at 3 kilometers. It always sees a single baseline solution. It's just what's contained in that solution from the server is going to be dependent on where you're at in the network. Nearest baseline, on the server side, the server uses the navigated position from the rover to deliver a single baseline correction from the nearest station, and of course corrections are only available within 100 kilometers of a station. We do not broadcast individual single baselines, so as there are some users out there that I know that have been accustomed to being able to connect into individual stations and select which station they want to connect into. We do not offer that option with SmartNet because of the logistics of managing 415 stations and then 4 different data streams from each station. That's 1,600 data streams that we'd have to manage. We cannot figure out a way to do it effectively. So we use Nearest, Max, and Imax. Question came up. Is it possible to view the cells we work in online? No, Jim, you're not able to look at the cells you have online. You would be able to very soon download a detailed log file to see what stations were in your cell. So we get asked on quite a few occasions, and I think there's kind of a question in here regarding this. Recommended practices. These are what practices that have been developed over time by both our experiences with SmartNet and using networks, but also by TSA, which is the Survey Association in the UK. They were commissioned by Ordnance Survey OS over in the UK to come up with recommended practices. This publication is on our website, so I encourage you to go over and look at it. I'll show you where it's at here in a second. But here's some practices that we recommend for different applications. So if I'm using primary control, so that's the gospel, what I'm going to be working off of now and into the future. We're going to do multiple observations. The traditional recommendation was either do these observations over multiple days or with a 4 to 5 hour spacing. This was to handle orbital differences and constellation differences, so we could mitigate their effects between morning and afternoon. Because we're able to do real-time satellite orbits now with a max correction, again, this is using network corrections here, we can achieve statistically similar results with only 45-minute separation between observations. So whereas we'd used to go out in the morning, take a shot on a point, come back in the afternoon, take another shot, average the two to mitigate the difference in the constellations, now I can come back within 45 minutes and get statistically similar results. We're going to observe over multiple epochs, so we're going to observe that point for between 180 to 300 seconds. Of course, this is personal preference and also just what you feel comfortable with. And then we're going to mean both our multiple epochs, and we're going to mean our multiple observations to be able to have our primary control. Temporary control, this would be where I need to drop a pair of points to turn a topo into some trees, where I can't get my GPS to work. So I'm going to drop a pair of points and I'm going to turn into them. I'm not going to set any other control off of this going forward. I'm just going to do some small work from those pair of points. I can do this with a single observation. I'm going to observe the points with the same initialization, however. So I'm going to observe it, point 1. I'm going to walk down range. I'm going to observe point 2, with the same constellation, with the same initialization. And I'm going to observe multiple epochs. So I'm going to observe with 180 to 300 epochs. Now the good thing that I think is with only a 45-minute separation, I now have the availability to possibly even, come back and occupy those 2 points again to be able to tie it in even tighter. That's not necessary, but it could be something you do. For topos, as-built, etc., I can do a single observation from 1 second and even roll that epoch rate up to 5. Question is, when you're setting control, do you recommend using static initializations? That's for a Leica receiver. A lot of people don't have the option. Sure, you can use that. That wasn't part of the test that we're referring to here. We've seen good results out of static initializations. That's going to be a matter of personal preference and a matter of what you do out in the field. Two points of emphasis for some of our new users, specifically out in Central California, where they were used to connecting in, not having to track any satellites because they were connecting directly to an individual station. We do have to have a navigated solution on the rover to be sent into the network to provision your correction. So the rover should have a complete navigated solution prior to logging into the network. If the rover does not have a position, the network will ignore the request for data, as it doesn't know what station or message needs to be sent. So if you're accustomed to being able to just connect in and then start getting corrections without having a solution, you're going to have to go outside, or you're going to have to at least have 5 satellites and a navigated solution prior connecting into the network. Another point of emphasis we want to make sure you guys know about is rover shutdown and disconnect. Rovers should always be properly disconnected from the network, so don't just turn your rover off. Actually hit shift disconnect or whatever method that you would use on your particular brand of rover to disconnect from the network. The failure to disconnect properly can cause a false socket to remain connected and actually lock you out of the network. So you want to make sure you disconnect. The other thing you don't want to do is just throw your rover in the back of the truck. If you just throw your rover in the back of the truck, it's on, it's connected, it's not tracking satellites good, it can cause a bad GGA string, a bad position to go into the network. When you turn it upright, the network doesn't get a new GGA string, and you're now 30,000 kilometers away, and you never resolve. So again, if you're going to put it in the back of the truck, make sure it's upright where it can track satellites. The best method is just to disconnect. If you're going to turn it off and go home for the day, don't just hit the off button. Don't just take the batteries out. Please disconnect from it. And if you're going to use it, you're going to have a navigated solution before you get it. A couple other notes from our friends in the Great White North up in Canada. They've been switching out some folks onto some newer modems off the older Edge modems with the new Telit 3Gs. This is specific for Leica. They're 5-band GSM, GPRS, and UMTS modules. They've seen improved latency, improved bandwidth, and with their initial testing has shown overall performance improvements because the difference between using a GPRS message versus using a 3G UMTS message. So if you're seeing some initialization problems, we probably want to look in a little bit deeper why these problems happen. Typically, these are going to be related to your cellular network issues, and these modems seem to have improved performance up in Canada, and should see the same thing here in the States. Okay, so let's do some housekeeping real quick on some of the questions. Daniel, please send a request in the contact for your question. Doug, on firmware, that should probably be handled through My World. That wouldn't be a us issue, but we'll take a note and answer that for you. Carlos, has there been any tests to verify the difference between 100 APIC measurements and 60 EPIC measurements? This comes with a site calibration from existing. The more epics that you have, the better mean average you're going to have of the motion in the overall GPS position. So that would be, again, personal preference. Again, we're just going off recommended practices that were developed by TSA. Jerry, I do not know what the status of the Verizon CDM module is. Traveling between points, the receiver's hanging out the window. Does this affect the correction? As long as it's tracking satellites, it shouldn't affect it. But again, if you're getting in the truck and you're moving, bad things can happen when things hang out the window. Will there ever be one cell phone card that will cover all networks? Maybe. That's going to be carrier dependent. There is a move in the market with AT&T and Verizon, for example. They are both moving to LTE, which is their long-term evolution 4G networks, but we're talking years and years and years. Yes, this presentation will be available online after. I think I got pretty much all of them. Curtis, if you will send your request in to us directly on the contact page, we will take that offline. Okay, so housekeeping, I think that takes care of, and Matt will show you that in just 2 seconds. Okay, so I think that takes care of all the questions we had so far, and so we'll get into real quickly what is SmartNet, just in case you didn't know. So SmartNet is a combination of Leica-owned reference stations, privately owned reference stations, stream data from other sources, DOT, private companies, counties, etc., that is managed and maintained, monitored by us, the SmartNet group, via a central data center by Leica Geosystems. It's an open network to all makes and models of GNSS equipment. We don't care, if you're green, red, yellow, blue, purple. We broadcast in the industry standard RTCM 3 transmissions so that anybody can use it. We do have to broadcast in some proprietary messages with CMR for some older agricultural equipment and 3D machine control. And we do, of course, provide nationwide coverage. So these are the major Leica reference networks in North America. The red would be the networks that we consider to be SmartNet. The light green are DOT or public networks, and the green are dealer networks that are still out there in operation today. So these are what we consider our affiliates, the green ones. The red ones are what we consider the SmartNet stations, the SmartNet networks. If you go to the website and you go to network coverage, you'll see the different colors. If you click on, if you're in one of the other areas, one of the affiliate areas, if you click on one of those states, it'll take you to that state's website or that dealer's website so that you can figure out how to get connected. If you do have questions on how to get connected to one of these other websites, you can always email us at our contact page or email us at our email address, and we'll try to help you the best we can. So SmartNet is built on the Leica Geosystems GNSS Spider software. Currently, SmartNet contains over 400 stations, providing GNSS network coverage in 15 states and 4 Canadian provinces, making it the largest GNSS RTK network in North America as well as the world. Under one umbrella in one house, we're about as big as it gets. And we have some pretty ambitious plans to grow SmartNet moving forward. One of the key components to SmartNet is our IT infrastructure. Leica contracts with the data center facility that specializes in IT infrastructure and server technologies. We're guaranteed almost 100% uptime. We have 100% power redundancy. We do have a full disaster recovery at a physically separate location. We have expansion capabilities available to us with a phone call. So we're not having to requisition new hardware if we're seeing bandwidth issues or anything like that. And we're currently operating 48 servers to service SmartNet North America. So we've spent a lot of time, effort, and energy into making sure that the back end can serve up for what the front end customer needs are. We've just completed our Eastern, Central, and Western U.S. transitions as well as our Canadian transition. So some of the numbers from our transition, just so you guys know, 400 plus stations have been transitioned to our new data centers. Over 2,000 rovers have been transitioned to the new data centers, and over 7,000 man hours was invested during this phase of our transition. A lot of sleepless nights, a lot of time on the phone, a lot of time behind a computer screen, but we've got it done, and we're happy to announce that we've reached our goal so far. So we have another development. We have gotten Spider 4.0 deployed to all of our SmartNet North American servers. This means we have an integrated rover and user database for all of SmartNet North America, whereas we actually used to manage 4 different databases. We now have 1, which is very nice for us. We have the ability to easily produce live status maps for reference stations. You can see that on the portal. We soft launched that about 2 weeks ago, but it is available today. There are still a few little kinks and bugs that we're working out, so please bear with us while we do that. It improved the performance and efficiencies on the network, and also improves our ability for coordinate management moving forward. We haven't implemented this, but we'll talk about that here in just a second. So the website. So first thing on the website I'm going to do is I'm going to actually pull up the question that keeps burning for everybody, is where do I get the UK paper? If you go to resources and downloads, TSA best practices here. That will take you to the TSA website where you can get the best practices that we mentioned back a few slides ago. Okay. So again, that's under Resources and Downloads, TSA Best Practices. If you click on that, it'll take you to the TSA website, and you can download it directly from there. Some of the key components to the website we want to make sure you guys are aware of course, are the network coverage map. The network coverage map is just going to show you where we have coverage. If you want live online station status, we'll have to take you somewhere else, but want you to see where you can kind of go get stuff. And the other would be how to get connected and some of the resources that are available. So quickly, under Resources, we have Connection and Configuration, Downloads, FAQs. If you ever have a question, how do I get connected? Come to the connection information page. If you have questions about just frequently asked questions, we try to keep them pretty updated on the FAQs. So if I want to get connected, I can simply hit get connected, the little phone icon at the bottom. I can then select what type of rover I have. Let's change it to System 1200, SmartWorks. I've got a GFU modem. I'm in, where do I want to be today? California. And I can choose, does my domain, my device support domain names, yes or no? If I hit this, it's going to show me my interrupt information, my domain name, smartnet.ca, my interrupt port, 10,000, and it's going to give me my 3 different mount points that I have available to me. And then it'll also give me connection and configuration quick guides down here at the bottom. Okay. If you don't know if your device supports domain names, you can hit no, hit get connection information, and it'll give you a server IP address as opposed to a domain name. We've been asked time and time again why we switched to using domain names so prevalently. The main reason is if we have to make any changes on the server side, then if you're using a domain, it's transparent to you. If we have to move servers, split servers, do anything that would require us to actually change an IP address, then if you're using a domain, you won't be affected. If you are using a hard IP address, you will have to make a change. And we will email those changes out, but this is just to try to save you some headache and your guys out in the field. So that's a connection and configuration guide. Again, I can access it in a couple places. Either get connected here on the main page of the website under Resources, Configuration and Connection Guide. Network coverage. Give it a second to render for you guys. Oh, yeah. So under network coverage, what we have is the ability to quickly see the different coverages in different areas. So with the network coverage map, come on, work. It's right after the top of the hour. This is one of the changes that we're moving forward and making. It's right after the top of the hour, so the web server is being hit pretty hard with data from the eastern U.S. and Canada. So we're going to be splitting those servers here soon. So it takes a second to process this. Well, this is okay. We'll have to come back to this. Don't know why that's not working. So that's the network coverage map. This should have worked. I apologize. I also have the ability here in the drop-down to pick network coverage by just selecting a specific area that I may be interested in working. On the coverage map also, I have the ability to type in a specific city, town, whatever I may need to look at. So I could type in New York, New York. And it's going to zoom me in to that specific area. Typically, we'd have the nice bubbles surrounding the area showing you where coverages are. There we go. So you can see that there is coverage in New York. I could quickly, again, type in Houston, Texas, and it'd take me into Houston to show me where I have coverages. Some people have asked when you click on here, what does all this mean? Operational status. These are up and online, but doesn't necessarily reflect the real-time status of what's going on. We can show you where to get that in just 2 seconds. So that's the network coverage map. I encourage you guys to come here, kind of poke around the website, get used to using it. If you have a question, you can always click on the contact link at the top. If you want to know a little bit more in detail about how Max, Imax, VRS, or any other methods work, you can come here to how it works and go to the RTK network, the future, introduction methods, etc. Okay, so I encourage you to kind of poke around, check it out, and see what you can find on the website. The other part of the website is the portal. So the front end, what I just showed you, is the marketing end of the website. So that's where you can get information. You'll find out a little bit more about SmartNet. But if you're a SmartNet user, we also have the portal that's specifically available to you guys. On the portal, we have the live status map, which I'm going to show you in just 2 seconds. We actually have a site database now with site logs, site pictures that we're still fleshing out, but we're with 400 sites and the need to add documentation, we're getting there. I'll show you that as well. And then Twitter updates. I know you guys probably don't spend a lot of time on Twitter, but I encourage you, if you're wondering what's going on with SmartNet, to check in there from time to time. It's going to have low-level messages, specific messages about things that don't affect everybody. For large outages, of course, we'd send out emails. You should have gotten an email earlier today about maintenance that's coming up this Friday. But for general smaller announcements, we're doing it a little bit more locally. So when you come into the portal, if you don't know how to log into the portal, let me pull that up real quick. If you don't know how to log into the portal, you can click Login on the main web page here. Once you click Login, it's going to bring you in to, assuming you use your login username and password, it's going to bring you into the live status map. This is a new feature that we just launched. I guess February 1st, it officially went live. It was a soft launch. We didn't send out an announcement about it because, again, we're still trying to work out some of the bugs. In here, you can see that we have a search tool, which has been asked for time and time again, so that you can actually search for a site code. So if I wanted to see, for example, TXAT, and I hit search, then it's going to bring up a box with information about at the station in Athens, Texas. It's information as far as if it's NGS status meets standards, it's not been approved. SmartNet site log, building mount photos. We've not got all the, of course, the ITR positions updated in here, but it does show me my NAT 83 position, what kind of receiver it is, if I needed to know, antenna. It's our RTCM ID. Of course, this is always important for folks to know what RTCM ID you're listening to. Conversely, we can also, if you have an RTCM ID, also come in and paste there, and it will now tell you what site that you're looking at. So we're trying to make this as very hard to see, read. If you come here to the website, you can poke around and find a little bit of information about it. I'm sorry I'm going fast. I know we're getting a little long on time here, and these are things that you guys can kind of poke around and see as well. Okay. The status map. The status map works from an XML we parse. The status map works from XML we parse from Spider, and when I say there's a couple little hiccups, the XML isn't the XML that we're being delivered by Spider isn't exactly right currently. So there are a couple stations in Texas, for example, that show down that are really up. Most of the other stations I think are reflected properly, but we can zoom in. For example, and like I said, there's a few stations here in Texas that are showing down that are actually up. Athens, Palestine, Yoakum, Corpus, Katy, quite a few of these stations are actually up. We're trying to work that out with Hairbrook. But you can see online shows me the circle with the red dot. Intermittent issues means that we've not been able to poll 100% of the data. We've polled less than 50% of the data for the past 2 hours, and offline means that we haven't heard from the station in 2 hours. We're still working with the timing. We don't want this to reflect instantaneously because we could literally have just a blink in which show the station is down and it doesn't poll for another 10 minutes before it shows the station's up again. So we want to make sure we try to manage that. I can come in here. I can click on the site and see, again, general information about the site. Where to download raw data, what the RTCM ID is, and again, this is a new feature. We're still, like I said, working out some of the kinks and some of the bugs, but this shows me the real-time status of the stations within about the last 10 minutes. So you can see that click on any of them, take you to it. Nice little handy tool. We're still working to iron out the bugs, but hopefully you guys will get a lot of use out of this. The other thing that we're using quite a bit now, like I said earlier, is Twitter. With Twitter, what we're doing is pretty simple. Is if we have small announcements to make, we don't want to inundate you guys with emails. We only want emails to hit you when it's big, serious things, like a webinar, like maintenance outage on Friday night, like some type of issue that affects a large segment of the population of SmartNet, as opposed to just getting down to the individual level. So if you come here, you don't have to register for Twitter, anything like that. You can see updates that we've made. 9 stations had site IDs changed to bring them in line with NGS and stations that already existed, either on our network or in NGS network. So again, we're doing this on Twitter because it allows us to post at one place, and then it also will post right here in this corner of the portal. Okay, so feel free to come around here, poke around, and start using the portal a little bit more in your day-to-day work. Oop, close that. There was the picture of the portal. Nope, wrong one. So you can see here, here's our Twitter. So 5 days ago, RTCM ID for St. Francisville was changed. Please visit the portal for more details. So you can come here and you can see the most recent, or you can click and it'll take you directly to our Twitter page. One thing that's under development, it has been under development for a while, is the user management portal. This is going to allow addresses some of the questions to look at detailed connection logs, which will show you all the auxiliary stations that were used to produce your Max or Imax correction for that day. It'll allow you to do rover usage graphics, mapping of usage, license and subscription renewal, rover username and password recovery, admin support and contact tools, modify equipment or contact information for your company, and all of this data is secure and only accessible by our staff or by your dealer or director of record. So this has been under development. We're still working on it, but as everything with software and bandwidth issues, we run into them every day. So we are working on this hard and heavy, and hopefully have it out here in the not too distant future. This is just a general mock-up of what it's kind of sort of going to look like. It'll show your company name. You can put start and end dates to show usage graphs through here, and then also be able to see connection logs down at the bottom for either a specific rover or all your rovers, and you'll be able to download that and tag it as part of your field book. So moving forward, we have a project that's underway that's called the SmartNet Initiative. This project will help us move SmartNet forward over the next 36 months. We have a very aggressive growth plan, and we're going to be upgrading and replacement of all the existing sites to complete GNSS receivers to make sure we have the most current GNSS infrastructure available out there. Along with all this, we've implemented more stringent requirements and standards of practice, and our team is involved in any expansion plans or site selection plans as we go forward. We've developed standard books for our internal staff so that they know what the standards are, so we can deliver that to either a dealer or direct in the area, so they can meet our standards, and also IT standards for a specific site should a site administrator have a question. Questions asked on a pretty repetitive basis: how do we install our stations? We make all efforts to install new stations in SmartNet to meet or exceed NGS specs. All the new sites are reviewed by our network specialists with installations done to assure high quality, low latency, and stable measurements are available for network processing. For old stations that we've inherited as part of our transitions and our growth, we're in the process of upgrading a large portion of these to full GNSS corrections where applicable. And if a station does not meet our standards, it will be upgraded along with the hardware, or it'll be analyzed for removal. This is a longer-term process. This isn't something we can snap our fingers and make it happen tomorrow, unfortunately, but we're working on it diligently to make sure that what we have out there is up to our standards. Another question that's asked on a pretty routine basis is how we position our sites. We want to make sure we provide a stable and reliable infrastructure on a standard reference frame. The reference frame that most people associate with networks is the NGS cores, and so we're always asked, are all the stations in SmartNet NGS core certified? The answer is pretty simple. Yes, some of them are submitted to NGS for certifications, but not all of them. The preceding question is always, why aren't all of them? Well, the stations in SmartNet must actually have a higher internal positional integrity than what NGS can provide. So NGS core standards are 2 centimeters horizontally, 4 vertically at a 200 kilometer spacing. Our standards require us to hold a 1 centimeter by 2 centimeter tolerance at a 50 to 70 kilometer spacing. So these two things don't fit together all the time. The good thing is NGS recognized this issue with requiring all stations in the RTM to be part and included in the national core system. So currently there's a committee producing specs to address both the operation as well as the positioning component of operational RTNs out there in the field. So how are we going to be positioned moving forward? Well, we've adopted this proposed NGS standard of inclusion of 10% of our stations in the National Cores Network. This assures that we can provide both the internal integrity we need at the same time of holding the National Spatial Coordinate Frame. And we're in prep currently to complete a complete readjustment of SmartNet by using LIGA Geosystems Geodesist with Bernice software, adhering to these proposed standards. We had ambitious plans to try to get this done in Q4, but once we started actually pulling together what this was going to entail, we had to back off that just a little bit. So with the adjustment, work is currently underway. We're identifying our existing sites that aren't already included in the NGS framework, which we're going to include. We're identifying existing sites to be submitted to NGS. We're identifying areas of need for expansion, relocation, remounting, whatever need be happen for NGS core submittals. We're performing site inspections, the site submittals, and more work than you really want to think about or know about. And it's really that comments for us, more work than we really care to think about on a daily basis, because it's a lot of details to be able to make this work for the scale that we're trying to do it at. The preparations are already underway. So when is this going to happen? We've already committed our resources to do this, and the adjustment will take place sometime in Q2 2011. We'd hope to make this coincide with the Q1 NGS release of the new Cores Epic, but we're not going to hit that. And as we go forward, all SmartNet stations will be adjusted to this new Cores Epic. And a few slides ago, I mentioned that Spider 4 allows us some advanced coordinate management techniques. This is important moving forward, especially for areas of high motion. So prior to Spider 4, a single coordinate was used for both processing and broadcast. The issues this caused in areas of movement, this experienced inconsistent network processing results. So, for example, in California, in Houston or Louisiana for subsidence issues, we could actually have problems that this affected. Or if we did make an adjustment to reflect these changes, those coordinates were immediately reflected to the user. So the solution for this is with Spider 4, we now have the ability to separate the processing and the broadcast coordinates. So we can have one set of coordinates in the background for the network processing and another set of coordinates that we actually broadcast out to the field users. This allows us, the network operator, to adjust the processing coordinates for optimal network processing, and allows users to complete projects without new transformations, adjustments, etc., having to be made if we had to adjust this on a quarterly or annual basis. So we're still looking at some of this. So the SmartNet adjustment schedule going forward, we're still developing this. We're still talking to folks out in the field in California and in other areas where this is going to affect of how we should best handle this going forward. But this will allow us to conduct continuous monitoring of the stations and then perform monitoring adjustments on the areas of movement on or subsidence on a quarterly basis if necessary, or perform monitoring adjustments on other areas on an annual basis. We're still trying to figure out how this can coincide with NGS and how we're going to make this all fit together. We're also trying to figure out the parameters. So when we're going to be adjusting these coordinates, if they differ than 1 centimeter and 2 centimeters, are we going to do it annually? How are we going to do it? So these things are still under development and under discussion. So we're not going to do this without a lot of thought behind it, and we're not going to make any changes to the coordinates of the stations without giving you guys plenty of notice. Question said, you said you missed it, but the Leica adjustment will be based on the new course adjustment. We were hoping to launch our new adjustment to coincide at the exact same time that NGS published theirs, is what I was meaning to say. So I don't mean missed it like we can't adjust to it. We will adjust. We will tie our adjustment to that. I was just saying we'd hoped to do it all at the same time, so it was kind of transparent, from a timing perspective. But we didn't hit the timeline that we'd hoped to. So upcoming dates, you should have got a reminder this morning. On February 18th, we're going to be conducting server upgrades and maintenance starting Friday night. Hopefully we get everything done Friday night, so Saturday morning everybody can go back to work and we can get some sleep. But if things stray over, full operational, normal operations will resume by 6 a.m. Monday morning. That's Eastern time. Remainder Q1 for 2011, just so you guys know, we've got upgrades and installations planned in Virginia, Maryland, Southern Louisiana, Houston, Texas, Southern California, Arizona, South Texas, and East Texas. If your areas don't fall into those areas, I apologize. We're working as fast and furiously as we can. Other Q1 projects is continued adjustment prep, and then in Q2 be able to roll that out. So with that, I will open the floor to questions, and I'm going to go back through some of these to see if we can get some house cleaning caught up. Dave, yes, send me an email about your move on the portal. Curtis, your question about GIS and RTK networks, please send a contact in for the portal. We'll get an answer to you offline. Roberts, what would you recommend, or how can I find out what would be the recommended between RTCM Imax or RTCM3 Max as far as our selection on our RTK screens? We would always recommend RTCM3 Max, but I would implore you to do some your own testing to see what gives you the best results. If you're using a Leica receiver, 1200 or Aviva, the Max is going to give you the best results. If you're using a different brand receiver, feel free to shoot us an email on the contact page, and we can take that offline, or you can talk to your local rep. Yes, this presentation is going to be available offline afterwards. Okay. There's a few questions that probably require, there's a couple questions that require, I think, their own webinar. Question was, are the auxiliary stations used for only for distance-dependent error correction? Does the actual coordinate of the auxiliary station affect the corrections? Yes, the coordinates affect the corrections in that it's a weighted, it's an interpolation, so your distance from each auxiliary station does matter on computing the models for the distance-dependent corrections. I'm not sure what you're meaning by the second part of your question there, Shelby. If you want to shoot us an email offline or give me a shout directly, I can try to take that offline. RTCM IDs, yes, they're the same on Monday as they would be on Friday. If you have a question about RTCM IDs, well, specifically to Imax and Max, the RTCM IDs would not change. If you're using a different brand, Trimble, Topcon, they should be the same. We do not change our RTCM IDs without notice. Coy, I'll send it to you again. We talked about RTK bridge. Can you help any cell problems? What is this? An RTK bridge is basically a radio and a modem slammed together so that you could set the unit where you did have cellular reception or put a high gain booster on it, high gain antenna on it, where on a rover you wouldn't be able to do this. And then rebroadcast the corrections via radio. We can, if you need more information, we can get it to you offline. Yes, we've thought about making webinars available in a PDF. We will make this recording available online on the website or via email. Yes, there will be a way for you to know which GPS epic is being used for the solutions being broadcast. Oh, PDH. You meant PDH as part of PDF. Gary, that's a difficult situation getting PDHs for webinars because we're in so many different varying environments and different states. Most states will allow you to submit something individually, and we're happy to help with that if we can. Send me an email. Send us a contact email. We'll be happy to do it. Okay, guys. Well, we've run a long time today. If there's no other questions, hopefully you got a little bit out of this. I'm sorry we had to move kind of fast, but we're trying to cover a lot of material. Again, poke around on the website, poke around on the portal. If you haven't spent any time on there, please do. Learn a little bit more about it. If you do have questions, the email address is on the screen right here. You feel free to shoot us an email, or you can contact us directly on the contact page on the main website if you can't remember this. We're glad you guys are part of SmartNet. If you're not part of SmartNet, we'd love to see you come on board, and I hope you guys have a wonderful, wonderful day. And with that, if there's no other questions, going once, going twice, sold. All right, guys, thanks a lot, and hope you guys have a wonderful day and have a good rest of the week.